Okay, so last topic of today will be the binomial theorem. First, a bit of a review. I always like to start off with a review of what we learned. So we learned about n factorial, this guy, n factorial, which is 1 times 2 times 3 times 4 up to n. All right? So for a quick example, here's a series of quick examples. 5 times 4 times 3 times 2 times 1. If you were to multiply those together, you get 120. For 3 factorial, so this is 5 factorial, is this. 3 factorial is 3 times 2 times 1, which is just 6. And 1 factorial is just 1. And we also said that 0 factorial was 1. And I'll talk more about that in just a moment. But first, the intuition is as follows. N factorial is the number of ways to arrange n objects. So if you have n objects, how many ways can you arrange them? So where the order matters. So I'll give you an example. If I have an alphabet A, B, C, that's my alphabet, how many words can I come up with? Not real words, but how many strings of letters can I come up with? So I have 3 objects, so 3 factorial is 6, so you'd expect 6. And let's list them out explicitly. There's ABC, there's ACB, there's BAC, BCA, then there's CAB and CBA. So that's 6 objects, and you see here that 3 factorial was 6. So that works. And how many ways can I arrange one object? Let's say I just had the object A. Well, there's only one way for me to arrange that object, and that makes sense. 1 factorial is 1. Okay, well, how many ways can I arrange 0 objects? Well, there's only 0 ways for me to arrange. Sorry, there's only one way for me to arrange 0 objects. And, here it is. That's 0 objects arranged. I know that might seem a little silly to you. If you accept it, a lot of what we learned today works out well. There's a reason to believe that 0 factorial is 1. I'm not just trying to pull your leg. So please take note of this. 0 factorial is 1. Very, very important. Okay. And just so I'll prove this right quick, that n factorial is the number of ways to arrange n objects should be n factorial. If I have n objects that I'm arranging, right? Well, actually, let me talk about the first example I gave. I had 3 objects, A, B, and C, to arrange. For the first object, I could choose either A, B, or C. So I had 3 choices. But once I make a choice for the first object, I only have 2 objects left. So if I chose A here, I only have B and C to choose from here, for example. So here I only have 2 objects, and once I've chosen 2 objects, well, here I've only had 1 object. So this is 3 times 2 times 1, which is 6. And in general, if I have n objects, for the first object I have n choices. For the second object I have n minus 1 choices, n minus 2 choices, n minus 3 choices, until I'm finally left with 3 choices, 2 choices, 1 choice. And that's just n factorial. Hopefully that makes sense to you. Okay, let's do some examples. Let's do some problems. Suppose I gave you the following. 4 factorial over 2 factorial. Well, the trick here is to write everything out. 4 factorial is 4 times 3 times 2 times 1. 2 factorial is 2 times 1. I can make these nice cancellations. I can cancel 2 with 2. 1 always cancels. 1 never changes anything. Dividing by 1 and multiplying 1 is the same as doing nothing. So 4 times 3 is 12. All right. What if I gave you something more complex? 8 factorial over 6 factorial. That looks really difficult, doesn't it? Because you're going to have to be doing a lot of multiplications. But actually, it's not so bad because you're going to be able to do a lot of cancellations here. So as you can see, the 6 goes with the 6, the 5 with the 5, and so on and so forth. And so this is just 8 times 7, which is 56. 56. All right. Good. And, let's do another one. Let's do 5 factorial over 0 factorial. If it weren't for this factorial, this would be impossible, right? You can't divide by 0, but you can divide by 0 factorial. Because this is 5 times 4 times 3 times 2 times 1, all over 1, because 0 factorial is 1. But that's just 5 times 4 times 3 times 2 times 1. It's going to be the same thing, and we said before, that's 120. All right? So those were some examples, some nice quick examples of factorial. All right. Here I'm going to introduce a new concept aside from factorial. Before, order mattered, but there are instances when order doesn't matter. I'm talking about words, for example. In words, the order of the spelling matters. But on something like a guest list, as we'll see, the order doesn't matter. If I was going to invite some of my friends to a party and I was making a guest list, the order that I put the names in wouldn't matter. It would be the same guest list if I rearranged the names. All right, so why is that important? Here you go. Suppose you had n friends. You had n friends, and you wanted to invite k of them to a party. So for example, you have 5 friends and you want to invite 3 of them to a party. You have 5 friends, but you can only invite 3 people to a party because social distancing. You have 5 friends and can only invite 3 of them. So, for example, I would have something like Alex, Bob, Kathy, Dylan, and Elizabeth. Right? These are my 5 friends, and I can only choose 3 of them. I don't have to choose Alex, Bob, and Catherine. I could choose Alex, Dylan, and Elizabeth, for example. And so what I mean to say here is also, the guest list Alex, Bob, and Kathy, this is the same as the guest list Bob, Alex, Kathy. These 2 are the same guest lists. So I don't want to count these twice. These are the same guest lists. I don't want to count them twice. How will I do this? N factorial won't work because if I used n factorial, if I used 5 factorial, this ABC would be counted as different as from BAC. But I don't want that. I actually want these to be considered the same. So this is, to compute this, you do 5 choose 3. This is not division. This is going to be a new operation. And this is 5 factorial all over 5 minus 3 factorial, 3 factorial. Okay. So what that means is, so I'm just going to compute it now. 5 times 4 times 3 times 2 times 1. 5 minus 3 is 2, so this is 2 times 1. 3 times 2 times 1 is 3 factorial. Now I can make my cancellations. 1 will always cancel, and the nice thing is this 2 will cancel with this 4 to make another 2. So this is 5 times 2, which is 10. So what this is telling me is if I want to invite 3 people of my 5 friends, I can do it 10 ways. And let's check that. We can just check that explicitly. So I have my 5 friends here, and I only want to invite 3 of them. How many guest lists can I make? Well, I can do A, B, C, or Alex, Bob, and Kathy, Alex, Bob, and Dylan, Alex, Bob, and Elizabeth, right? And the order here doesn't matter. So I'm not going to write CBA as its own guest list because that's the same as ABC. Okay, let's keep going. ACD, ACE, ADE is another one. And there's BCD, BCE, BDE, and finally CDE. Okay, so these are the 10 possible guest lists that I can make where I invite 3 people from 5. So you can. This is of course not a proof that this is always going to work, but this is just an example. So let's make this formal definition. Oops. Given a set of n objects, the number of ways to choose k objects is given n choose k, which is n factorial all over n minus k factorial, k factorial. All right, so this is just, I'm not going to prove that this does work. The proof is actually the proof that I have is pretty nice. I don't think anyone's, well no, I think I've seen it before someplace. But the proof I give is pretty nice, but only if you're willing to see it. If you're willing to see the proof, come to office hours and I'll give it to you. But otherwise, I think we've established trust. That is to say, you can trust me. All right, so let's do some examples here. Let's compute 5 choose 1, and I always like to think about what's going to happen. 5 choose 1. So I have 5 friends, and I want to invite one of them. How many ways can I invite one of my 5 friends? Well, there should be 5 ways, right? I could choose Alex, I could choose Bob, I could choose Kathy, Dylan, or Elizabeth. I can choose, there are 5 ways for me to choose one friend, 5 friends. So let's see if that works. Let's see if I get 5 at the end of this calculation. So this is 5 factorial times 5 minus 1 factorial times 1 factorial. This is 5 times 4 times 3 times 2 times 1 all over. 5 minus 1 is 4 times 3 times 2 times 1, and then 1 factorial is 1. And now my favorite part, you can do these cancellations. This 1 also goes away, so the answer is 5. And yeah, that makes sense. So I can, if I have 5 friends and I can only invite one of them, I have 5 ways to, I have 5 possibilities. Okay, good. Now something a little bit more difficult. 6 choose 2. If I have 6 friends and I can only invite 2 of them over, how many different combinations are there? Let's see. So this is 6 factorial times over 6 minus 2 factorial times 2 factorial. So let's just write everything out. The trick is to just write everything out. 6 minus 2 is 4, so 4 factorial is given as follows. 2 factorial is 2 times 1. Okay, let's do everything out here. This 4, this 3, this 2. These 1s will go away. This 2, I can cancel that with this 6 to make a 3 up here. And this 1, of course, goes away. So this is 3 times 5, which is 15. All right. So that what this means is if I have 6 friends and I can only invite 2 of them over, there are 15 different possible guest lists for me to make. Another one, let's say 3 choose 3. That's odd. Well, let's think about what this is saying. 3 choose 3. I have 3 friends, and I want, how many ways can I invite all of them over? Well, if I have 3 friends and I'm inviting all of them, there should be only one way for me to invite all of them. I just invite all of them. So let's plug that in. This is 3 minus 3, 3 over 3 minus 3 factorial times 3 factorial. Okay, so this is 3 factorial all over 0 factorial times 3 factorial. But we said 0 factorial is 1. So this is just 1 times 3 times 2 times 1. And everything cancels out. We're just left with 1. Okay, and that makes sense. If I have 3 friends and I'll invite all of them over, I only have one possible guest list in that case. I just invite A, B, and C. So that works. And notice that if 0 factorial was defined to be 0, we wouldn't be able to do this calculation. But since 0 factorial is 1, we are allowed to do this calculation. So this is pretty nice. Okay, so I think that's enough for the examples. Let's see here, what else? Just looking through my notes. Okay, so this was not the binomial theorem. This was just a precursor to the binomial theorem. We'll talk about the binomial theorem in the next few slides.